Okay, illustrative math, unit 2, lesson 22 is called solving rational equations. So before we start the lesson, I want to do a little bit of a review. Some of this is algebra 1. Some of these are algebra 1 skills. If you are strong with this, feel free to fast forward the video, but a proportion. A proportion is two fractions equal to each other. So if this is a proportion, the way that you solve a proportion is you cross multiply. So I take 5 times 80, and I set that equal to 10 times x. And then it's all in one line. I don't have any fraction now, so I can just divide and get x equals 40. All right. Now if I have something like this, and I'm just making this up, so it might not give us a nice whole number here. Let's just say 1 over x. So let's multiply, cross multiply. 3x equals 1 times x plus 1 is just going to be x plus 1. 2x equals 1. And I get x equals 1/2. Okay, so that's how you solve a proportion. Okay, factoring with the box method. So if I have this box here and I want to factor it, okay, first thing I'm going to do is I'm going to split it up. I'll just do both of these right now. And you're kind of going backwards. You know that the x squared goes here in the top left and the 20 goes down here. So the only way to get x squared is x times x. And now we got to think, these two boxes have to add up to 12x. So I got to figure out how can I multiply to get 20. And, some people might be tempted to try 4 and 5, but the problem is this would be 5x and 4x. And when you add these up, it doesn't give me the 12x. So we got to find another way to do it using factors of 20. So I think the ones that work are 2 times 10. So then what ends up happening, this works, 10x plus 2x is 12x. To get it factored, I get x plus 10 times x plus 2. Okay, now if it said to solve and find the solutions, since it equals 0, we would say x equals negative 10 and negative 2. Those would be the solutions. Okay, over here, you put the 3x squared there and the 7 there. So 3x times x. And then you got 7 times 1, which would give me 1x and 21x. If I add those up, it does not work. Now, I need this to be negative, so you might figure out real quick that these are going to have to be negative. But I think I'm going to have to switch them. I think I'm going to have to put the 1 here and the 7 here. And why did I choose negative? Because negative 7 times negative 1 is still positive 7. And then you add these up. So they add up to negative 10x. So it's 3x minus 7 times x minus 1. So your solutions are x equals 1 from this one. And then if I set that equal to 0, sometimes people can't do that in your head. Just remember, set equal to 0, move the 7 over. So it's positive 7 divided by 3. There you go. Okay. So solving quadratic by factoring, you should be able to do. And then the last thing here is the quadratic formula. So if you have a times x squared plus b times x plus c equal to 0, quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c, whole thing over 2a. So I'm going to go to this first. I'm only going to do one of these here. I'm going to take that x squared plus 12x plus 20 equals 0. I'm going to identify a, b, c, And I'm going to say negative b plus minus the square root of b squared minus 4 times 1 times 20 all over 2 times 1. And then I'm just going to do my math. I should get the same numbers. I should get negative 10 and negative 2. So I get negative 12 plus or minus, let's see what that'd be, 144 minus 80, I think. Hang on a second. So I get 64, okay. So it's negative 12 plus and minus 8 over 2. So now I just do negative 12 plus 8 is negative 4 divided by 2. And then I do negative 12 minus 8. And then when I reduce these, I get negative 2, negative 10. Just like I had exact same up there, okay? All right, now we can move back onto the lesson. So goals. I can solve a rational equation algebraically, and I know how to check for extraneous solutions. Now, this is a new word here, extraneous solutions. Extraneous solution is a solution to an equation that emerges from the process of solving the problem, but is not a valid solution to the problem. Okay? Usually happens when you have x in the denominator. So, if I have 3 over x plus, let's make that x plus 8 equals 2. Okay? So you could cross multiply, or another trick is to just multiply by your common denominator. And when you come here, these cancel, so you just get 3. And when I come over here, I get 2 times x plus 8. It ends up being the same as cross multiplying. But you do your algebra and you get your answer. But what happens is, let me make that a little neater. What happens is, if you look at this in the if you look at this in the denominator, okay, what you should know is, oh, if x is negative 8, I'm going to get 0 in the denominator. And you should know that you can't divide by 0. If you're not sure, take any number in your calculator and divide it by 0, and your calculator will give you an error. All right, so on to the warm-up. What do you notice? What do you wonder? So I noticed the original is a proportion. Okay, and then let's see here. What else do I notice? So instead of cross multiplying, what they did was they just multiplied by the common denominator. And what happens is your fractions clear out. So since this would be my common denominator, they both have an x minus 2, and then this one has an x. The whole thing is your common denominator. What happens here is these cancel out, so I just get the 3. And over here, these cancel out, and if I distribute the x into here, I get 2x squared plus x, okay? So now I move the 3 over, okay, and we have a quadratic equation. Why is it quadratic? Because it's x squared. So I wonder, can I finish it? Can I factor to solve? Or do I need to use the quadratic formula? I would also notice here at the original one, x cannot equal 0 or 2. Why? Because if I plug 0 in here, 0 times, it'd be negative 2, is 0, so you can't divide by 0. If I plug in 2, 2 minus 2 is 0, so 0 times 2 is also 0. So that's another notice. Let's see here. Could I factor it? Let's try it. 2x squared negative 3. So this is going to be 2x times x. I need this to be, how about a 1 and a negative. Now let's make that a -1 and a +3. It's going to be -2x, 3x. Those add up to 1. Cool. So I got 2x plus 3 times x minus 1. So x equals 1 and then -3/2 as well. So there's my answers. Okay. So Jada's working to find values of x to make this equation true. She says, if I multiply both sides by x times x plus 1, that would be your common denominator there, I find that the solutions are x equals 1 and -1. But when I substitute -1, the equation does not make any sense. Is Jada's work correct? Show or explain your reasoning. So, okay, so for 1, I'm going to multiply by x times x plus 1. So I'm multiplying the whole thing by that. So when I distribute here, the x plus 1's cancel, so I get x times 5x plus 5. And when I come over here, the x's cancel, so it's just 5 times x plus 1. Let's distribute this out. I get 5x squared plus 5x equals 5x plus 1. When I minus the 5x's, those cancel. So I get, oh, I'm sorry, that should have been a 5. Sorry, 5x squared equals 5. Divide by 5, x squared equals 1. All right, her work looks right. I got 1 and -1. But when I plug -1 back in, it doesn't make any sense. So let's plug it in. So I take 5 times -1 plus 5 over -1 plus 1 equals 5 over -1. They should be equal. So I'm going to just do the math. This gives me -5 plus, I get 0 over 0 equals -5. That doesn't make any sense. I think she's right. So I'm going to say yes, she is correct. And then here's all my work. So why does Jada's method produce an x value that does not solve the equation? So we learned this word earlier. So there you go. So I think 1 is good, though. Let's plug in 1 just for the heck of it. 5 times 1 plus 5 over 1 plus 1 equals 5 over 1. Does that work? This would be 10 over 2 equals 5. And then sure enough, yes, it does check out. 5 equals 5. So the 1 is good. So you only have one answer, x equals 1. You got to throw out the -1. All right, here are a lot of equations. For each one, use what you know about division to identify values of x that cannot be solutions. So anything in the denominator, so can't equal 0. So I'm going to say here x cannot equal 2. This is the only x down here, so this is going to be x cannot equal 1. This one here can't be 0. And this one can't be 2. This is the same thing. X can't equal 0 or 2. This one here, if I set these equal, if those give you trouble because they look a little different, set it equal to 0. And we would get, oh, okay, well, if x equals 0, this whole thing, 3 times 0 is 0. So remember, it's x cannot equal. Over here, I'm going to say x can't equal 3 for this factor and 0 for that one. X can't equal -8 and then 8. 0 and -1. And -1 right there. Okay, so those are all of your values of x that it cannot be. So basically, if you go ahead and solve these equations, if you get these values for x, you got to throw them out. They cannot be solutions. So I already did this. I said without solving, identify 3 of the equations you think would be least difficult to solve and 3 that you think would be most difficult. Be prepared to explain your reasoning. So I'll start with the easy ones. I said this one's easy because it's going to be linear. If I cross multiply, I don't get an x squared. Okay. And then I said this one here. Why did I say that one? I thought I wouldn't get an x squared, but I do actually. I would say this one's easier just because when you cross multiply, you just have less x's in here. Like if I look here, I got 1, 2, 3, 4 x's. I got an x squared. Um, there's no multiplying. So this one, I chose this one because they both have an x as a factor in the denominator. Now this one I would say is hardest here because when I multiply these, cross multiply like a proportion, I'm going to get an x cubed because I'm going to get x squared times x. That's going to make it hard. Same thing here. I'm going to have to multiply x plus 1 times x plus 2 times x plus 1 when I cross multiply. So that's going to give me an x cubed. And then this one, I said this one was harder just because I have two different factors in the denominator. And when you multiply, we're going to have to FOIL. And then we also have a 3x there. And yeah, I'm probably going to have to use quadratic formula. So, all right, let's pick one of the easy ones and solve it. So I'm going to do C. C looks to be super easy. So cross multiply. So you got two options, actually. You could cross multiply or you could multiply by your common denominator. So I'll show you both ways. If I just cross multiply that, I get 5 times x plus 8 equals 10 times x minus 8. Or if I were to do the common denominator thing, I'd multiply x plus 8, x minus 8 times the whole thing. And I'll erase this after I'm done, but I just want to show you. And when I come over here, the x plus 8's cancel, so it's just 10 times x minus 8. And then when I come over here, the x minus 8's cancel, so it's 5 times x plus 8, if that makes sense. Okay. All right, so let's go ahead and distribute this. I get 5x plus 40 equals 10x minus 80. Let's move the 5x over to the right. Let's add 80 to both sides. 120 equals 5x, divide by 5. Okay. And then you want to plug it back in. Make sure you don't get a 0 in the denominator, which 24 plus 8 is 32, so we're good. 24 minus 8 is 16. All right, let's try one of the hard ones, I guess. Or let's try another one of the easy ones. It says, I guess I should have done this down here, but let's choose another one of the easy ones. Maybe let's do F. So I'm going to cross multiply again, so I'm going to get x times x plus 1 equals x times 1. I'm cross multiplying. And then this ends up becoming pretty easy. X squared equals 0. X equals 0. Now the problem is I have to throw that out because if I plug it back in, 1 divided by 0, that's undefined over here. So that's not going to work. So I actually throw it out. So this one ends up being a no solution. Okay. And let's try one of the harder ones. Let's do, I don't know, let's do, let's do G. So x plus 2 over x, 3 over x minus 2. So when I cross multiply, I get 3x equals x plus 2 times x minus 2. I can make a box to multiply that out, but it's going to end up being x squared minus 4 because the 2x and the negative 2x will cancel. So again, this is another one here that it's going to be a little bit harder when I move the 3x over. I got to subtract. I'm going to have to factor this. So make your box. Whoops. So that's going to be x and x. I think it's going to be minus 4 positive 1. 1, yeah, that'll give me 1x and negative 4x, which gives me that negative 3. So x equals negative 1 and 4. Okay? Now, I also want to plug them back in. This was my original. If I plug in the negative 1 here, it works. If I plug in the 4 here, it works as well. I get 6 over 4, which reduces to 3 halves. And if I plug it in here, I get 3 halves. Okay? Same thing with the negative 1. It works. I get negative 1 and negative 1 when I plug them in. All right, so how can extra solutions arise in the process of solving an equation? And so there you do all algebra and get a solution, but when you plug the solution back into the original equation, your solution does not work, okay? Always check answers with rational equations, okay? Anytime you have x in the denominator, always check it. All right, so I know how to check for extraneous solutions to rational equations. So identify all x values that make the equation true. So I guess it should probably be equal to 0 maybe. Or wait, hold on. Let me double check that. That came out kind of weird. Or maybe that minus sign is supposed to be an equal sign. It's supposed to be an I think it's supposed to be an equals. Yeah. Scratch that. All right. So you could cross multiply or multiply by your common denominator. Okay. So, oh wait, no. Whoops. Hold on. That's not right. So I've done a lot of cross multiplying, so I'll go back to the common denominator. So your common denominator is x times x plus 3. So when I come over here, these x's cancel. X plus 3, x minus 3. When I come over here, the x plus 3's cancel, so it's 8x. So let's distribute this. I get x squared minus 9. And again, if you need to multiply that, make a box. You get the x squared, 3x, negative 3x, and negative 9, and these ones cancel out. Move the 8x over to the left, and x squared minus 8x minus 9 equals 0. So now I got to get this factored again, or go to the quadratic formula. So I put the x squared here and the negative 9 here. Obviously x times x. So this one's going to be negative 9 and 1. Multiply those to get negative 9. These have to add up to give me negative 8x. So it's a little bit of a guess and check game here. So I get this whole thing factored into x minus 9 times x plus 1 equals 0. So I get x equals 9 and negative 1. And then when I plug them back in to check, let's do the 9. 9 minus 3 over 9 equal 8 over 9 plus 3. Let's see if it works. 6 over 9 equals 8 over 12. Now you might say, well, those don't look equal, but if you reduce them both, they both equal 2/3. So the 9 is good. Let's check the negative 1. I get negative 4 over negative 1 is 4. And this is 8 over 2. That's 4 as well, so that works. So those are your answers. Okay. All right, I hope you enjoyed this video. Thank you for watching.